Hello anatomy students. Today we are going to be going through the joint chapter. I believe that is chapter 8. I used to combine that with bones, but things are different now. So I had priorly titled this joints major title heading. So this is going to be the start of our joint notes. I'm going to do a fairly brief version of these notes. I'm not going to go as in depth as your textbook does. If you're interested in this, I hope you are appreciating some of the coloring, which probably presents this much better than I could. So, we're going to start off with a little bit about what joints are. So joints are also called articulations. These are functional junctions between bones. So it is where one bone meets another bone. They bind parts of the skeleton together. They make bone growth possible. They permit parts of the skeleton to change shape during childbirth, namely the pelvis. They enable the body to move in response to skeletal muscle contraction. So, without joints, if we were just one solid skeleton, our muscles would be kind of useless. They allow us to move. It is how bones are joined together. So, not all joints are the same. We are going to classify joints in a few different ways. We're going to classify them structurally, we're going to classify them functionally, and then we're going to go through some different types of joints. So, first we're going to go through structural joint classification. The three classes of joints are fibrous joints, cartilaginous joints, and synovial joints. A synovial joint is what you think of as a joint, like the joint in your fingers or your elbow or your hip or any of the big things that actually move have synovial joints. A fibrous joint, a good example of a fibrous joint is the sutures that hold your skull together. So the sutures that hold your skull together are fibrous joints. There are cartilaginous joints. Those you have as your intervertebral discs is what are some of your most obvious. There is one in between your two pelvic bones. And again, most of your joints that you think of as joints are synovial joints. So there are also functional joint classifications. There is some overlap with this and the structural joint classification. So there are synthrotic joints. These are immovable. So the sutures of your skull are synthrotic. They can't move once they are developed. They're permanent. They're not moving like the way my mind at least thinks of a joint as something that moves. So then there are amphitherotic. These are slightly movable. So what counts as slightly movable is like these cartilaginous joints of your spine. Your spine has ability to move. It doesn't have ability to move like my elbow or my fingers or even my hip has ability to move. And there are diatherotic joints. These are freely movable. These are going to be your synovial joints. So these diatherotic joints, they're going to be synovial. They are going to have a large range of motion. So I have this in here just to remind you of a little bit of evolutionary biology as we go. Just as a reminder, we are homologous in our bone structure to like every other vertebrate. So moving on, we're going to go through fibrous joints first. So fibrous joints have dense connective tissues connecting to bones. These joints exist between bones that are in close contact. There are a few different types of these. There are Syndesmosis, that is the joint that we have between your tibia and fibula. It has a special name. There are sutures. Sutures hold your skull bones together. So it holds these flat bony plates together. Then there are gomphosis. I may have butchered that word. It's the name of a joint that holds your teeth to your mandible or your maxillae. However, your teeth are not considered bones. They are actually a part of material. They are not homologous to bones. So a syndesmosis is a sheet of fibrous tissue that connects bones. They're amphitheatic. They lie between the tibia and fibula. So you have this immovable joint, which is why your lower leg doesn't seem to have the motion and rotation that your upper limb does. So you have sutures. These are thin layers of connective tissue that connect bones. These are going to be between flat bones. They're synthrotic. They're immovable. So later this week, I'm going to have you start working on learning the bones of your skull. It's not too bad because they are in pairs. Everything that's on this side's got to be on that side. One thing to note when you go through this is a lot of people have sutural bones where, like, this is not a named bone of the skull. This is not a named bone of the skull. These are parietal bones. This is the occipital bone. But many people have sutural bones where there's a part where these bony plates didn't come together. Another bony plate developed that is unique to that individual. Although not that unique of a phenomenon. Then there is a gomphosis. Sorry if I'm butchering that name, which is a cone-shaped bony process in a socket, tooth, and jawbone. These are synthrotic. So these are immovable, hopefully. So it is binding tooth to the bone. Okay, this is going to bring us to the cartilaginous joints. So cartilaginous joints are either going to be hyaline cartilage or fibrocartilage connecting bones. There are two different types of these. So there are syncretus and synthesis. So with synchondroses, there are many bands of hyaline cartilage that unite bones. So you have a whole bunch of these joints that are temporary. Your epiphyseal plates, where you have bones that are growing, are temporary synchondroses. They are, strictly speaking, a joint. Bone, line of cartilage, but these are temporary. It is how that bone is growing and developing. You have it between your mandible and your first rib. They are going to be synthrotic. The other type is a synthesis, which is a pad of fibrocartilage between bones. So you have a few examples of this. You're going to have this in your intervertebral discs and a pubis synthesis, which is a joint. So, and then the joint between adjacent vertebrae, so your intervertebral discs, and your pubic synthesis, where you have this pad of fibrocartilage connecting your pelvis. So these are amphitheatic. They are slightly movable. I can move my spine. I can't move it as much as I can move a synovial joint. So that finally brings us to synovial joints. A synovial joint is at least what I think of as a joint. If I say something is a joint, I'm generally talking about a synovial joint unless I've made another point about it. But these are diathoracic. They are freely movable is what we call them. But these are going to have a joint cavity and synovial fluid. There will be a joint capsule, synovial membrane, and brusae. So these are much more complex. They have larger moving structures because they have to provide a range of motion. So there are a few different types of synovial joints. So we're going to go through the types of synovial joints now and places where they can be found. So you have gliding joints. You find these between your carpals and your tarsals. So these allow for a flat, planar motion. You have hinge joints. Probably the easiest hinge joint to demonstrate is going to be your elbow. It's a very nice hinge joint. So we have your ulna hinges very well with your humerus. You also have these at your phalanges. They have very nice hinge joints. Then you have ball and socket joints. You have two ball and socket joints. Your shoulder is a ball and socket joint. It has a fabulous range of motion. Your hip is a ball and socket joint, and I don't have as much range of motion there. You have condyloid joints. These are between your metacarpals and your phalanges. So here we got your hand. So these bones here are your metacarpals. These are within the body of your hand. So these are then your phalanges. So you have these condyloid joints, where it's sort of like a little ball and socket situation, which is what lets my fingers do this and all of the little things that can happen at this joint that can't happen at these two. You have pivot joints. You have two famous pivot joints. You've got a pivot joint with your radius and your ulna that allows your arm to do this, which is rather handy. Get it? Handy. You also have a pivot joint with your atlas and axis. Allows you to rotate your head. You have a saddle joint between the carpal and metacarpal of your thumb. So that is going to be like two curved over things that fit and can ride on each other. That is what allows your thumb to have the even greater range of motion that it has. So between your carpal and metacarpal of your thumb, you have the saddle joint. Well, it's here. It's not here. It's here. And that's what allows your thumb to do all of its thumb-like things. All right, so that is all of the more joint notes I'm going to give you. I am going to be giving you some sort of virtual ID quiz for the bones of the skull. I think again, it'll be numbered. If you don't get it right, I will put in the note which numbers you did not get right. If you want to then resubmit, it tells me if you resubmit, so I can go back and take another look at it. So you can expect that in a day or so, but thanks for watching. Have a good day.